Okay, today I'm going to talk about differentiation. This lesson actually take one of the extended lesson from the limits. Okay, in limits, you are know there can be we can create some equation for the derivative of the very basic functions. Okay, you can take what is there. If I take like this, did you remember? There are some basic functions. We taken some derivatives of what? If I take y equal ex, what is the differentiation? Otherwise, the derivative of this one. You can take this on what? If y equal ex, what is the derivative of this y? That should be derivative of this y dy by dx. What is the meaning of this one? Derivative of this y function of x. You can write like this, okay? Derivative of y function of what is subject? Subject of x. Yes. What is the meaning of that one? So you have to keep in mind it should be x. dy by dx equal for ex. Okay. There are very basic function like this. If I take y equal ln x, so according to that, dy by dx equal for ln x, what should be there? 1 over x. It is 1 over x. If I take y equal xn, so dy by dx equal for n compressed x n minus 1 like that. If I take y equal sin x, dy by dx equal for what is there? If y equals sin x, it is dy by dx equal to cos x. If y equal cos x, dy by dx equal for minus sin x. Okay, and if y equal tan x, what is the dy by dx equal for tan x? What is the sec squared x? Okay, sec squared x. If y equal the other trigonometric functions on our side, it should be yes 1 over sec it should be cosec x. No, if I take sec x, dy by dx equal for sec x tan x. Yes. If y equal cosec x, it is dy by dx equal for minus cosec x cot x. Yes. If y equal for what is the other one? Cot x. Yes. Y equal for cot x, dy by dx equal for what should be there? This should be minus here tan x sec squared x. So this one cosec squared x, but it should be minus. Another three value, if y equal, what should be there? Other values sin inverse x. Yeah, there should be. If y equal sin inverse x, it should be dy by dx equal 1 over square root of 1 minus x squared. No? Yes, 1 minus x squared. Y equal cos inverse x. It is dy by dx equal for 1 over 1 minus x squared, but there it is minus. Y equal tan inverse x. It should be dy by dx equal for 1 over 1 plus x squared. These are the very basic equation. So normally for in this question for your A-level examination, you have to keep in mind at least this equation. Otherwise, you can't get the full marks for the differentiation question. No, so these are the very basic what formulas that needed to do the differentiation question. So we are through this equation by the lesson of length limits. By using that one, you can use this basic equation for the each and every parts. Okay, now you have to keep in mind these things. Okay, so here is this part. I believe you have to remember this equation. Okay, so you can use this equation. Did you remember? Yes. If I take what is the best one, again I will tell what is there. If I take first equation, tell me. If I take ex, derivative also ex. If I take ln x, what is the derivative? It should be 1 over x. If I take xn, it is n x minus n minus 1. Yes. Sin x, it is cos x. Cos x, it should be minus sin x. Yes. Tan x, it is sec square x. Yes, x squared x. Yes. And yes, sec x, it is sec always go to tan. No? Sec x, tan x. Yes. Cosec x. Yes, it is minus cosec x into cot x. Yes. Cot x minus cosec squared x. Yes. And there are some inverse values. Yes, inverse trigonometry values. So you can take sin inverse x. It is 1 over 1 minus x squared. Yes. Cos inverse x, it is minus 1 over 1 minus x squared. Yes. And last one, tan inverse x. There are no square root, 1 over 1 plus x squared. These are the basic equation. Okay. There should be some pattern. You can see. However, you have to keep in mind. Okay. You can create your own pattern. It's okay. Okay. But there are, you can see, there can when I in A-level I take in what? There are some equation. Look at it. When always, if they are having C letter of C, this always having the minus. No, it is always having the minus. When it is C, it is always having the minus. You can see. And always the sec is gone is the tan and cosec is gone in the cot. Likewise, you can take any equation. Okay. When tan and cot, it becomes viscous. No? Likewise, you can take the equation. So, first of all, if they are having an addition and the subtraction of the equation, you can just do the derivative by that one. If I take, for example, like this, if I take what? Y equal sin x plus x cube. Likewise, you can just do the derivative of this one. How? So what is the differentiation of y? It should be dy over dx. Dy by dx. Yes. Dy by dx equal for what? Dy by dxy. I wanted to what? Derivate this y, function of y, by the subject of x. So normally we are writing it as a dy by dx. What is that? Dy by dx. Okay. So sin x. What is sin x? Sin x derivative should be cos x. Yes. Plus x3. How to take it? Tell me how to write x3 there. If they are having x3, you can take 3 front. X 3 minus 1, it should be 2. 3x 2. You can write this as 3x power of 2. Clear? There it is like this. Okay. So If I take y equal, tell me some value, uh, sec x5 minus tan x. Okay, so how to do this one? Dy by dx equal 4. Tell me, sec x. What is differentiation from sec x? It should be just like this one. What is there? Sec x tan x, sec x tan x. Yes. Here, if they are having powers like this, you can take front here 5x minus of this one 5x pro minus tan x. What should be there? Sec x squared x. You can write like this, no? The third one, y equal ln x plus ex, yes, plus sin inverse x, yes, minus cos x. Okay. How to do this one? Just if they are having addition loss subtraction, you can just do it with the inside. Okay. So there should be dy by dx. It should be equal for ln x. It should be what? 1 over x. Yes. Ex plus. If they are having sin inverse x, it should be 1 over 1 minus x squared minus cos x. Cos x should be minus sin x. Okay. Now minus and minus it become plus, no? You can just do like that. Okay. These are the very basic. Yes, this is. This should be the very basic. If they are having some numbers with there, sometimes there can be some variables, no? You can include the variables for this equation. So how to do that one? Let's move with that one. Okay, if I apply the variation with this one, you can apply the variation for these values. Okay, there can be apply some variables. What are the variables you can add for these values? Okay, if I take some values in the variables, if I take y equal 3 sin x plus 2 tan x minus 5 sec x. Okay, so you can just, these are the variables, no? You can keep that constant variable and you can do the derivatives. What is the meaning of that one? If I take like this, so dy by dx equal for what is? There are 3 times of sin x. So you can write it as 3 times of what is derivative of sin x? It should be cos x. 3 times of cos x. Just write down that one. Yes. Here 2 times of what should be there? Sec x squared x minus 5 times of what is there? What should be there? Sec x and x. You can just do it. Okay. You can just what? Do the derivative with the variables. Okay. You can write what should be there? Y equal, if I take 4 tan inverse x, yes, plus 2 x5, yes, minus 3 cot x plus 5 ln x. Okay. So how to do this one? Just write down 4 times tan inverse x. Tan inverse x, it should be 1 over 1 plus x squared. Just do it. Plus 2 times of x5. x5 should be x to the power 5. 5 came first. And x 5 minus 1. It should be 4. Minus 3 times of cot x. Cot x should be 1. Cot x minus cosec squared x, yes, plus 5. ln x should be 1 over x, yes. Now simplify this one. 4 into this only 4 over 1 over x squared, yes. 2 into 5 it is 10 x4 minus into minus it should become plus, no. 3 cosec squared x plus here 5 into 1 over x, 5 over x. You can simplify like this. Clear? I believe you got the point, no? Yes. You can simplify this value. Yes. Easily. And tell me, what is the derivation of this one? If I have the derivation of yes, y equal 3 sin x plus 2 tan x plus 9. Okay. What is the derivation of this one? Yes, what is differentiation? If I take this one, what should be there? Dy by dx. It should be 3 into sin x. Sin x, it should be, you familiar that term, cos x plus 2 into tan x. Tan x, it is sec squared x and plus, what is the derivation of 9? Are there any constant number here? No. We wanted to what? Derivate this by subject of x. Are there any included x there? We are derivate this y by the subject of x. So is there any value with regarding with the x? Is there any value including x there? No. There are no x's. There are no x's. So what is the derivation of this one? It should be 0. When you have the what? When you have constant value, the derivative always should be what? The differentiation of the constant value always should be differentiation. Yes, differentiation of constant value. Constant value. But what happened? Always should be, yes, always should be 0. Yes. Differentiation of the constant value always become 0. Now keep in mind, you have to another one. If they are having differentiation with the constant value, it becomes 0. Yes. Yeah. If I take y equal 5 sec x plus 95 minus cos x. Whatever. You can take dy by dx, yes. 5 times sec x should be what? Sec x tan x, yes. Sec x tan x plus this one become what? 0. No need to add this one. No need to consider this one. No need to write actually. Minus cos x. Cos x would be minus sin x, yes. Now you can write. It is 5 sec x tan x minus into minus become plus sin x should be there. You can write like this. Clear? For hereafter you can write like this, no? You can take the values like this. In the very basic of the thing. Clear? Okay. Any doubts? Okay. You can ask any doubt in the comment section, okay? No issue. You can put the comment. These are the very basics. Okay, if you know about this equation, you can get marks for the limits as well as the differentiation also. Yes, yes. Okay. After that, you have to know about what? Differentiation of the multiplication. Okay. Yes. Let's you have to know about differentiation of multiplication. There are addition and subtraction on. For multiplication, we can't apply like this. Okay. Just derivation. There are not a no. There should be another equation. Okay. You can't just take in the derivation of several variable multiplication of the several variables. Okay. So if I take differentiation of multiplication, yes. Okay. How to do this one? Differentiation of the multiplication. So, actually, we call this method as product method. Yes. Product method. No. Yes. So if I take variable as y equal u into v. Yes. There are two variables. Multiplication of two variables. So I wanted to take the differentiation of this one. So I wanted to take differentiation of this one with the subject of x. Yes. So you can write this one as dy by dx. Dy by dx. Yes. Dy by dx. First of all, look at here. I write this one. I write this variable and multiplication of derivative of other variable. So if I wanted to take v with the what subject derivative v with the subject of x, so it should be dv by dx. When you are taken y derivative of y with the subject of x, we are writing that one as dy by dx. No, like that you can write v subject of x. What is dv by dx? And put plus mark here, u other one dv by dx, and write v other one du by dx. Du by dx. This one should be the equation. Yes, yes. This should be the equation of the derivation. So, what is the equation? Just tell me. Tell me. U dv by dx plus v du by dx. This is the normal equation of the product rule. I know you can't understand like this, no? It is better to show you that one with the normal example. If I take y equal what is ex sin x. Okay, yes. Write it as ex sin x. Yeah. Now tell me how to write this one. Dy by dx. Dy by dx equal. First of all, write this one ex and derivation of other one. What is the sin x derivation? It should be cos x plus. Now I write other first sin x. So what is the derivation of ex? It should be ex. You can write like this. Clear? No. Not much. Okay. One more. If I take ln x tan x. Okay. Now tell me dy by dx equal 4. If I take ln x, you write first part. There are two variables. Can you identify ln x and tan x? No. I write the first variable. What is the ln x? And derivation of the other one. It should be what? Tan x. What should be the x squared x plus. Now what is the other part? I write tan x and derivation of this one. It should be 1 over x. You can just write like this. Okay. Simply take this. These things are simply okay. You can what? You can show this equation with the limits also, okay? Yes, yes. You can justify it, yes. Absolutely. ln x and tan x. It should be ln x other part, sec squared x plus tan x into other part, 1 over x, yes. If there have some variables, that means if there have some constant values, you can just keep them and you can write it, okay? What is the meaning of that one? I don't know. You see? Yes. If I take y equal 3 into sin x and tan x, okay. If I take like this, there it is multiplication, but they are with the what? With the numbers. You can write it as dy by dx equal 3 into what should be there? Sin x, derivative of this one, it is sec squared x plus, and write tan x. What is the derivation of sin x? It is cos x. You can write like this. Okay, after that you can simplify this one. No? 3 into sin x squared is 3 plus 3 into tan x cos x. Likewise. Okay, if I take y equal 5 cot x ex likewise. Okay, so you can write it as dy by dx equal for what? 5 into what should be there? Cot x, right? Derivation of ex, it is ex plus, you can write ex. What is the derivation of cot x? Cot x should be minus cosec squared x. And after that you can simplify k minus front likewise. Okay, if they are having variable in front of this one, you can simplify it and write it. Okay, that's a very basic. There's the multiplication of the derivation. Okay, and next I go to the what? Last part, division. Division of the derivation. Okay, division. It is same like that. If they are having division, how to do that one? You can write, if they are having variable like y equal u divide by b. Okay, I wanted to take the division of this one. How to write? You can write it as dy by dx equal, first of all write down one, denominator, yes, v, and write the what? Derivative of numerator. It should be du by dx. Numerator, derivative of what? Derivative of numerator plus. Is it right? Minus? Plus? No. When it is division, it should be subtracted. Okay? Just minus. And upper part, what should be the u, and the derivation of downward. That means derivative of the numerator is dv by dx and divide by square of downward. That means square of the denominator. So there it is a pattern. Look at it. First of all, write down one and derivative of upper one minus upper one, derivative of down one, and divide by down one square. You can write like this. Okay. You can just write like this. That's an equation. Okay. Look at it. If I write y equal sin x divided by ex. Okay. How to write this one? You can write dy by dx. Yes. First of all, derivative ex and the what? Derivative of the numerator, it should be cos x. Ex cos x minus, and write numerator sin x and the ex divide by, there should be ex squared. Ex squared, you can write it as e2x in this here. You can write like this. That's only. If I take here y equal uh, tan x over cos x, okay. It should be dy by dx equal for, first of all write cos x and derivative of tan x, it should be sec squared x minus, and write upper one tan x into derivation of cos x, it is cos x, what is there? Minus sin x, and divide by down on square, it is cos squared x. You can write like this. Here minus into minus, it become plus. Minus into minus, it become plus. You can write like this, no? Yes. These are very basic. You know what is the derivation of what is tan x? Tan x equal for what? Sec x what x, no? I can prove that one. What is the tan x? Tan x equal for sin x over cos x, no? I can prove this equation by the derivation of the division. Yes, yes, you can prove. Yes. How to do that one? If I take y equal tan x, okay, how to write that one? Y equal sin x over cos x. Now tell me, dy by dx equal for, first of all down on cos x and the derivative of sin x. Derivative of sin x, it is equal for minus cos x minus, and upper one sin x, derivative of down on, it is sin x, yes. Here plus x cos x, sorry, minus sin x, yes. Divide by down on squared, it is cos squared x, yes. Now cos into cos, it is cos squared x minus into minus become plus sin squared x over cos squared x. You know sin squared x plus cos squared x equal for what? 1, no? So this value is equal for 1. You know this value is equal for 1, no? This is equal for 1. Now final answer is equal for what is there? 1 over cos squared x. 1 over cos x, sec x, no? So this one equal for what? Sec squared x. Yes. You can write like this, no? So dy by dx equal for what? Sec squared x. You can find that answer like that, no? You can find easily. Always sin squared cos squared equal for 1. I think you got the point. So, if I summarize, what is the multiplication? Y equal uv, it should be dy by dx equal for u into dv by dx plus v into other one into du by dx. Okay. So, other one, y equal u divide by v, it should be dy by dx equal for, if you can write down on first v and derivative of other one du by dx minus, and you can write upper one u dv by dx divide by down 1 square v square. These are the equations. Okay. These are the very basics. Okay. Now you can apply these things for the several ways. Okay. They can ask what is a second derivation, third derivation, likewise. Okay. So you have, if they are asking second derivation, you have to derivate it again. And if they are asking third derivation, you can take it as a derivate that one again. Like that one, you can find the derivatives. Then there can be ask a question with the several. These are the basics. So you can apply this basic with the several ways. Okay. So we will see how to apply these things. Okay. So we will see that one on the next video. So thank you very much.